Hello guys, this is for the week of, or actually this recording is for class on Monday, April 19th, and also my Tuesday, Thursday class, April 20th. Guess what? We only have 3 more sections, so that's exciting. So Monday, Tuesday's class is only section 7.3. The slideshow I sent you has the rest of this entire unit, but tonight we're just going to focus on 7.3. So we are working with logarithms. I've sent you this PowerPoint to make sure any page that I skip over, make sure you read through that, like this one, for example. And so we're going to start solving some problems. All right, so this first one says to evaluate log base 2 of 32. So what is that? What is that saying? Basically, it's asking you to think of what number 2 raised to what power equals 32. That's what basically this is asking you. You take this base 2, raise it to an exponent, and get 32. What would that number be? Well, that exponent would have to be a 5. Therefore, log base 2 of 32 equals 5. So we can kind of keep this in mind as we go from logarithmic form to exponential form and vice versa. So here's the first few problems we'll look at. So this says 2 to the third power equals 8. Well, that's true. Of course it does. We're going to convert this to logarithmic form. So going back to that original problem, I asked you what is log base 2 of 32, and we said the answer is 5. And this means the same thing as 2 to the 5th power equals 32. So let's keep that pattern in mind. So basically that base, that little tiny number, is our base of our log. So log base 2 of 8, equals 3. So these two guys are going to trade places, right? And the 3 becomes a large number. All right, well, the second one is written kind of, if you think of it backwards order of how the first 2 we've looked at is written. So this number that's raised to the power of 4 becomes our base. So log base 5 of, and these two guys trade places, 625 is equal to 4. So that exponent becomes a large whole number down here at the end. The last one, we're going to say the log base 7 of z equals x. Okie doke. All right, let's see what else we have. So now we're going to do the opposite. Now we're going to convert from exponential, or we're going to convert from logarithmic form to exponential form, but I'm going to have to erase this right here so we can see it all. All right, so how would we write that? So we're going to take our base, our little number, we're going to start there, make it a big number, raise it to the power of 2, and we're going to set it equal to 9, right? And we know this is true, right? We know that 3 squared equals 9, so we feel good about our answer. On this one, we're going to take that base, that's where we start. We're going to raise it to the third power, and we know that 8 to the third power is 512. And then this last one, we're going to continue the pattern. We're going to take the base of 2, bring it up to the y power, and set it equal to x. Now this one we can't check. We don't know what x and y are, but since we followed the pattern of these two, we can be sure that our answer is correct. All right, now this one is basically asking, so if you have a log and there is not a base written, that means it's always a 10, log base 10. And most of our calculators all have, when it says the log button is always log base 10, there's one great calculator, it's a Casio. This one you can actually change the base of your logs, but most of the other ones do not. But anyway, so basically, let's say, well, we're trying to figure out what this is equal to. So thinking back to what we've just done, didn't we take that base, We raised it to this power and we set it equal to this big number. Well, this big number, because we've been practicing with exponents, we're more familiar with this number written as a fraction. This number is tenths, hundredths, thousands, tens, thousands, 10,000, excuse me. This is 1/10,000th. That's what this number is. So you remember our exponent rules? If we want this number to jump down in the base, we're going to raise it to a negative exponent. Well, our negative exponent would be 1, 2, 3, 4. So 10 to the negative 4th power. Remember, we said, okay, if it has a negative exponent, we're going to throw it down to the bottom. And then we would write this out as 1, 2, 3, 4, 1/10,000th. So we can figure out that this answer right here is actually true because these are equivalent. So basically what this equals is -4. All right. Let's look at the second one. Oh, I've given you those steps. All right, what about this one? Well, according to those patterns we've been doing, we would take 1/8, raise it to the power of x, and we want to know what that exponent would have to be to make this number equal 64. Well, if I put a 2 right here, I would get 1/64. So how would I make this thing flip? Wouldn't I do basically 1/8 to the -2? And that would give me +64. So this would equal -2. This one was -4. All right, I want to explain why to you, but now guess what? There's better news, you guys. Better news for sure. Well, at least for the first one, excuse me. At least for the first one. This one, your calculator will do this one for you. It will do this one for you. So you're going to take your calculator, you're going to hit the log button, and you're going to type in 0.0001, and it tells you right away the answer is -4. Now this one, this problem right here, I'm going to show you in a few minutes how to do, probably actually the next lesson, probably either Wednesday or Thursday. I'm going to show you how to find the answer out if you don't have the Casio that changes your base, your log bases. If you have this calculator, you can type in this problem exactly like it's written. Log base 1/8, 1/8, and in parentheses, you're going to put 64, and it spits out the answer -2 for you. But unfortunately, this awesome calculator that I do love, you can't do it on that one. But I'll show you in our next class how you would do that problem with a calculator. So it's good, depending on which calculator you have, no matter which calculator you have, it's good to know how to do this by just figuring out the answer on your own. All right, so what about this problem? So let's go with our pattern we've started. We're going to take that base. We're going to raise it to this power, 3/5, and that's what x equals. Well, you can plug this right into your calculator, or you could think of it, remember those exponent rules, when we have a number raised to a power, a fraction power, it would be 32 to the 5th, basically it would be the cubed root of 32 to the 5th power, which you could also plug right into your calculator. But why not? Let's keep it easy. Let's make it very easy on ourselves. Let's just get our 32, raise it to the power of fraction 3/5. And it tells me the answer is 8. The answer is 8. That's what x equals. Okie dokie. Oh, I did that one for you too. Remember our exponent rules, blah, blah, blah. All right, what about this one? So we're going to take that base of 4. These two guys are going to trade places. We're going to raise 4 to the power of 2, set it equal to 5x. Well, now what can we do? Well, we can actually square 4. 4 squared is 16 equals 5x. And we want to solve for x. The only way to get rid of times 5, we're going to divide both sides by 5. So x is equal to 16/5. So that is our answer, 16/5. Okay. All right. 16/5. There we go. All right, now these, you're going to have a couple of these in your HOGS. It's going to tell you to write these equations in logarithmic terms. Do not simplify your answer. So how are we going to do these problems? Well, first of all, we're going to get this exponent right here. Well, let me read. I like it when it was written the other way. 2x equals 3.6. All right, so let's go back to that original problem we had. We said 2 to the 5th power is 32, right? And the original problem was the log of 2, the log base 2 of 32 equals 5. So I always like to go back to this original problem, and then I can kind of follow the patterns and figure out what I need to write. So this raised to the power becomes the base of our log. So we're going to do log 19 of 3.6 is equal to, and that exponent becomes our number out here. And so guess what? That's our answer. And so in HOGS, that's exactly what you're going to type. 2x is equal to log base 19 of 3.6. Okay. All right. So let's think about this example, and we're doing this one. That number raised to an exponent becomes the base of our log. Log base 4.8. And then these two guys trade places. Of G equals 4. So when the direction says do not simplify, this is exactly what HOGS wants. This and also this. Okay, so you'll have a couple of those either in your practice or your certify, or you know what, probably both. All right, now the other thing we're going to do is we're going to, you're going to have to graph logs, or not really graph them, but you're going to have to be able to pick out a graph from a log. Okay, so I'm going to rewrite this into the form that we're starting to get used to, right? We're going to take the base of our log, make it, that's what we're going to always start with. We're going to raise it to the power of y and set it equal to x right there. Okay, so now we already have a t-chart going on right here. So on this problem, let's see, 3 raised to what power would equal, well, let's start with, you know what, I'm going to make my own t-chart. I don't want to worry about this particular t-chart. I'm going to just worry about y for right now. Okay, so what if I raised 3 to the 0 power? And that would be y, right? That's my exponent. What's 3 to the 0 power? Well, anything to the 0 power is 1. All right, what if I raised 3 to the 1st power? What if y was 1? What would x be? What's 3 to the 1st power? 3 to the 1st power is 3. All right, what if I made y a -1? What would be 3 to the -1st power? Well, when we have those negative exponents, we have to drop that down to the denominator, and I would see 1/3. Okay, so I can graph these 3 ordered pairs, and I'm going to see what my graph looks like based on that. So I'm going to go right 3, 1, 2, 3, up 1. The second ordered pair tells me to go right 1 and stay. And the third ordered pair tells me to go right 1/3 and then down 1. Excuse me, yeah, down 1. So basically, I'm going to have a graph that has this curve like this, and it's going to go down forever. So that's what my base, that's what this is going to look like graphed. Okay, so this is called like a base function. This is called, you know, your very basic logarithmic graph. Now, of course, they are going to get more complicated, right? And so once they get more complicated than just something like this, we basically think of our original graph of a base function, and then we are going to transform it. So basically, let me show you what I mean. Oh, I'm going to do one more before we talk about transformations. I'm sorry, I forgot about that. All right, so let's do this one. Let's start with the base of our log, which we're going to start out with. 1/2 raised to, remember we can always write g of x as y, raised to the y power equals x. Okay, so once again, we're going to make our own little simple t-chart. And we're going to say, all right, well, what if we want y to be 0? What's anything raised to the 0 power? The answer is 1. All right, what if I want y to equal 2? Let's say I want y to equal 2. So what would be 1/2 squared? Well, it would be 1/4, right? Well, what if I want to flip it? What if I want to flip this fraction? So I'm going to multiply it by a negative number. So let's say, what if I make y equal -2? Well, that would be 1 to the -2 over 2 to the -2, which would make both of those flip. So basically, I would get 4. So if y is -2, x is going to be 4. All right, so I can graph these 3 points. I can figure out what this is going to look like. So the first one tells me to go right 1/4 and up 2, about right there, very close to the y-axis. The next one tells me to go right 1 and stop, and the next one tells me to go right 4 and down 2. So I can see what this graph is going to look like, right? So if I'm given a choice of 4 coordinates or 4 graphs and it tells me to pick which one and this goes with, I would be able to do that pretty relatively easy as long as I make my little t-chart. So now this is what I'm going to talk about functions. So basically, if you have your base function like this and you see something like +5, that basically is going to make your graph shift up 5 units. All right, well, if you have your base function and then you see -3, that means that whole original graph is going to go shift down 3 units. All right, now if the +3 is in the exponent, normally +3 means that you're going to go right on a coordinate plane, but when it's part of the exponent, it's actually going to go left 3 units. The opposite's true. In the exponent, if I see x -3, that means it's going to take that original graph and it's going to shift it 3 units. And then when we take that original base function and we make it a negative, that whole graph's going to be reflected over the x-axis, right? Also, all of these can be written in this form, and you have the notes, so I'm not going to reread these to you. You can look at them. But you know what's a lifesaver, you guys? What is a lifesaver? Desmos, absolutely. So I'm going to take a picture of this graph, this equation, so I can see it, and we're going to switch over, and we are going to use Desmos. So let me stop sharing for just a minute. I'm going to find Desmos on my computer. Beautiful math, isn't that what it says? All right, so I'm just going to simply type, I'm not even putting f of x or y equals. I'm just going to start with my log. So if you come down here to functions and you go to miscellaneous on the end right here, and I assume we all have them in the same spot, right here, log base A. So on this one, our base is 3. And in our parentheses, we're going to write x plus 2. And then outside parentheses, we're going to put +1. That's exactly what I just saw. So I'm going to take a mental picture of a couple of spots. I see that my my y-intercept is just below 2. So 0, probably, I don't know, 1.6. And then my x-intercept is going to be -1.60, okay? So it's always going to give you 4 choices of graphs. You're going to go to Desmos. You're going to see what it looks like. You're going to make a mental picture in your head, and then you're going to go back to Hawks, and you're going to pick the right graph, Okay, so you can absolutely graph the original, the base function, and then you can make those transformations the way you want to according to what I just shared with you. Or you guys, don't we just love Desmos? Don't we just love it? I think we do. So that's what we're going to use, you guys. We're just going to use Desmos. I even put here, we're going to start with our base function, and then I re-explained to you what x plus 2 means. It means you're going to shift the whole thing left, and then the plus 1 means you're going to take that original function after you shift it left 2, you're going to shift it up 1, or we want to do Desmos, right? So I'm not going to take the time to graph these for you because it does it for you. All right, so here's a good problem we need to look at. So let's rewrite this one first. Let's take the base of our logarithm. We're going to make it our big number. We're going to raise it to the power of a -1, and we're going to set it equal to 2x. And once you just kind of start rewriting these, either from logarithmic, from logarithmic form into exponential form and vice versa, once you start going, okay, well, I know what, I'm not sure exactly how to do this problem, but I know I can do this, it's going to kind of come to you and you're going to kind of figure out what you need to do. So we've already talked about our exponent rules this unit. So you know that 6 to the negative first power is 1/6 equals 2x. Well, now what would we do? What makes sense? Well, you're going to solve for x. So the only way to get rid of times 2 is divided by 2. So we're going to divide this by 2, which means we're going to keep it. If we divide by 2, that means we're going to keep it, change it, flip it, and x is equal to 1/12. That is the answer. X is equal to 1/12. And of course, if you write it as if the directions say round to 2 decimal places, make sure you divide 1 by 12 in your calculator and you round that correctly. All right, what's next? Oh, there we go. All right, what about this one? Well, what do we know we can do? Well, we know we can take that base, we can raise it to power of 5 and set it equal to 8x. Well, 2 to the 5th power, I'm going to throw that in my calculator. 2 to the 5th power is 32. So 32 is equal to 8 to the x. And then we're going to divide both sides by 8. Well, so the answer is 32/8, but I can divide both of those numbers by 8, and the final answer is 4. The final answer is 4. Uh-oh, that's not what I got on my paper earlier. Ooh. Did I do it wrong? What's 2 to the 5th power? Uh-oh. I wrote on my paper it was 5/3. What did I do wrong? What did I do wrong? Oh, maybe I actually solved it step by step by step. Did I? Oh, okay. On this one is where we would rewrite. This is where we can rewrite 8 to the power of 2 because of our exponent rules. I have somehow made my pen yellow. What in the world have I done? Thank you guys for being so patient with me. I mean, you don't really have a choice. I send you these videos, right? Oh, because it's not 8x. I apologize. It's 8 to the power of x. So that's what I did wrong, you guys. I was just setting it equal to 8x. So I wrote that incorrectly. I'm glad I checked my answers on my paper. I did them earlier so I could make sure I kind of know what I'm talking about. So yeah, so that makes sense to me now. So we have 2 to the 5th power is equal to 8 to the x. And when we talked about our exponent rules last week, we said, well, one way we could drop this whole number is if we can make them equal. So think about, how do we write 8 as a power? So well, 2 to the 3rd power is 8. Y'all remember that? And then we're going to bring down that exponent. So now that our bases are the same, the 2's are the same, we get to drop those. And now we have 5 is equal to 3x. And then we're going to divide both sides by 3. So x is equal to 5/3. All right, good. That makes more sense. We always make mistakes, I guess, right? Okie doke. All right, very good, very good. All right, now what does it say here? It says use the elementary products of logarithms to solve the following equations. Write your answer as a fraction reduced to the lowest terms. All right, so basically on this one, we're going to take that base. We're going to start with that number, raise it to the power of 2/7 equals x. We could kind of think of this as, you know, the square root of 128 to the 7th power, or you know what, we really don't even have to do that because we can put this right here directly into our calculators. So I'm going to write 128 raised to the power of the fraction 2/7, and my calculator tells me right away the answer is 4. And of course, this is going to also tell me the answer is 4, either way. All right, let's look at the next one. We're going to take that base, start there, raise it to the power of 3 equals, now this time it is 5x. It's not 5 raised to the x power. So what is 3 times 3 times 3? So 3 times 3 times 3 is 27. We're going to solve for x by dividing both sides by 5. So that doesn't simplify, and it does tell me to give your answer in fraction form. We can't divide 27 and 5 by the same number, so that's our final answer. All right, now this one, you can put this directly in your calculator, but basically what it's saying, remember if I said it didn't have a base, it's the base of 10. So think of this problem this way. 10 raised to the x power is equal to 10. What would that be? What would 10 raised to what exponent would give me 10? Well, the answer, of course, is 1, but we don't even have to think that hard because in your calculator, if you write the log of 10, hit equals, it tells you the answer is 1. All right, now earlier I told you that probably Wednesday or Thursday I would tell you how to convert this if your calculator doesn't have an option to change the base of your log, but I lied because I'm telling it to you now. So basically, this looks simple, except if your calculator doesn't have the power to change the base of your log, you're going to have to know how to do this. So the way you're going to do these problems is you're going to have to take the log of the big number first, which is 64, and you can divide it by the log of the little number. And you know what? I just realized we don't have to do this yet. Okay, both of these are going to give us the same answer, but I'll show you. So anyway, I wish I'd started with this example. I wish I'd started with saying, okay, guys, let's look at it this way. Let's take the base. That's what we're going to start with. We're going to raise it to the power of x, and we're going to get 64. And then I would challenge you, it seems like we've already done this problem anyway. I would challenge you to think of what number our exponent would have to be to flip this guy, flip it, right? Well, how do you flip a fraction? You'd have to have a negative exponent. So wouldn't that be -2? Is it 1/8 to the -2nd power 64? It is, it is, it is. All right, but anyway, so that's the right answer. However, let me just continue since I started talking about this. So anytime you have the log of a base other than 10 of a number, and you have to do that, you can do it in your calculator, even though you can't change your base. So in your calculator, this is what you're going to do. You're going to bring up your fraction form. Excuse me, your fraction. Bring up your fraction, hit log 64, arrow down to log fraction 1/8, hit equals, and it told me I made an error. Oops, let me try it again. Log of 64 over log of 1/8. And it's telling me I made a syntax error. Let me trade calculators, see if this one does it. Fraction log of 64 over the log of 1/8. Oh. If I figured out how to do my calculator correctly, log of 64 over the log, nope, I can't, oh my gosh. The log of 64 over the log of 1/8. 8. -2. Okay, for some reason, this calculator gave me the right answer, but the other one didn't. So picky, you guys. So either way you think of, if you can figure it out this way, fantastic. If not, now this is the pattern of how you always would do those problems if your calculator can't change the base of your logs. All right, now what is the natural logarithm of e? So on your calculators, all of you have a little e with a little power button next to it. Most of us have to hit the shift key to get to the natural e, okay? So on my TI-30XS, the e to the x power is over the LN button. So I would shift, and I would use the LN button. On my Casio, it's also over the LN button. So it's a natural logarithm of a number x. The natural logarithm of a number x is defined as the base e logarithm of x. So this is what I want you to look at right here. E to the first power is e, which would be to the first power, okay? The ln of e is always equal to 1, the ln of e. The ln, you have an ln button on your calculator. The ln of e is always equal to 1. So what does that mean? The ln of e to what power do you think would equal 20? What would x equal? Well, x would equal 20. So you'll be using that kind of thinking, and not only this class, but in your college algebra class, okay? The ln of e to the 20th power is equal to 20. The ln of e is always 1. All right, now here's a particular problem. It doesn't really have to do with the natural log, but here it is. So in your calculator, this section right here, if you have a problem like this part is put into your calculator exactly like you see it. So log base 10, if you don't have to type that in because your calculators are set to log base 10, plus you have the Casio, or you have that button too, of 9186. The answer is 3.96313 is equal to 6x. Okay, this goes straight into your calculator right here, this section. And then if I want to solve for x, what would I do? What's the opposite of times 6? The opposite of times 6 is I would divide this number by 6, and my x is equal to about 0.6605. That's what x equals. 0.6605. Yep, that's it. So we're going to use our calculators as much as we possibly can. All right, let me go to the back of my paper just so I can always check myself, make sure what I'm telling you is correct. All right, so remember what I told you earlier, the ln of e is equal to e. So the ln of e to the x, what would the x power have to be to equal 19.7? Well, x is equal to 19.7. And you have a couple of those in your Hawks and you're like, I don't know what this means. Well, it is that easy. So when you get this particular problem right here, whatever this number is, that's what this exponent is. Okie dokie. All right, once again, if you see a problem like this on your this goes straight in your calculator, guys. Your calculator already knows what the log base 10 of 5,000 equals. So put in your calculator, log of 5,000 is equal to about 3.699. So then to solve for x, I'm going to take that number, I'm going to divide it by 2. So don't clear your calculator. All you're going to hit is divided by 2, and then make sure you round correctly 2 decimal places. So according to my calculator, I have 1.849. So 2 decimal places, I'm going to look at the number in the thousands place, and I'm going to say, okay, what does an 8 do to a 4? It changes it into a 5. And if you don't round correctly, it's going to mark the whole thing wrong. All right, now these are getting a little bit more complicated, but we can do this. Now, let me just go over something with you. So we have this big exponent right here, and we want to get it out of the exponent section. We want to bring it down to be a whole number, regular number. Okay, so the way you do that, to get your exponents to move down, you're going to find the log of both sides. So you're going to find the log of this side. Whatever you do to one side, you're going to do to the other side. As soon as you find the log of this number, that whole exponent drops down to the front. So in other words, we're going to have 2 minus 5x log of 3. And this side is going to equal to the log of 11. Okay, so basically this is like a multiplication problem right here. So now, we're going to, you're going to do that several times, so you'll get used to that, but you need to make sure you write that in your notes. How do you get the numbers up in the exponents to come down and not be in the exponents? The answer is you find the log of both sides. So now that I've done that, I want to solve for x. Well, I want to get rid of everything that's on the side of x. Well, this whole side is being multiplied by the log of 3. So how do I get rid of times the log of 3? I'm going to divide both sides by the log of 3. So this is gone and this is gone, log of 3. So what am I left with on this side of the equal sign? I'm left with 2 minus 5x equals, this goes directly in your calculator. So in my calculator, I'm pulling up a fraction bar. I'm typing in the log of 11, scroll down, arrow down, and then I'm putting on the bottom the log of 3. Log of 11 over the log of 3. And I get about 2.1827. Okay, don't round too quickly. Okay, so let's go out about 4 decimal places. So now I still want to solve for x, so I have to next get rid of positive 2, which means I'm going to subtract 2 from both sides. Whew, didn't mean to do that. So that's gone. I bring down negative 5x equals, so this number still in my calculator, I'm going to write minus 2, just type minus 2. It gives me about 0.18266. Now, how do I get rid of times negative 5? I'm going to divide both sides by negative 5. So x is equal to, in my calculator, I'm hitting divided by negative 5. And my answer is about negative 0.037. And make sure you read the directions. What does this say? Express the answer exactly as a decimal approximation. Okay, so that's pretty close. All righty, let's do the next one. So that's the first one. Let's do the next one. All right, so we have this exponent right here, this big exponent. We don't want it to be an exponent. We want to bring it down to the front. So how do you do that? The answer is you find the log of both sides. So once you find the log of both sides, you get to bring this decimal down in the front as a regular number, not an exponent. So I'm going to write 4 divided by x times the log of 5 equals the log of 134. So how am I going to solve for x? Well, first thing I'm going to do is do the opposite of times log of 5. I'm going to divide both sides by the log of 5 by the log of 5. These are gone. So I bring down 4 over x is equal to, I'm going to put this part in my calculator. My fraction button, I'm going to say the log of 134 over the log of 5, and it gives me a number. 0, 4, 3. Oh, shoot, you guys, what did I do? Oh. Did I lose it forever? Oh, I did not. Did I? No, I did not. Okay, sorry. I freaked out. All right, so now I want to get rid of divided by x. So the first thing I'm going to do, the opposite of divided by x, I'm going to multiply both sides by x. That's gone. So now 4 is equal to 3.043. Oh my gosh, I did it again, you guys. What is wrong with me? All right, so x. So now I want x by itself. How do I get rid of times 3.043? I'm going to divide both sides by 3.043. 4 divided by 3.043. And on my calculator, I'm going to put 4 divided by, and then in this TI-30, to recall your answer, you can hit second. And then above the negative number, you see A and S. So it's telling you, you're basically telling it to recall an answer, second, and then A and S, and it recalls your last answer. And the answer that my calculator tells me is 1.3144. That's the answer. All right, you might have to go through that question, that statement or that problem a couple of times, okay? All righty, let's try one more, you guys. All right, so how do you get these exponents down to not be exponents? What's the answer? You take the log of both sides. Now this is a long problem, but make sure you take good notes, okay? So once I took the log of both sides, I get to bring down 3x minus 1 times the log of 5 equals x plus 3 times the log of 2. All right, this is a long problem. We need lots of paper to write on. Are you guys ready? Because now we're going to have to distribute everything in the parentheses on both sides of the equal sign. So we're going to say the log of 5 times 3x is 3x times the log of 5. And then this says minus 1 times the log of 5 is equal to x times the log of 2 plus 3 times the log of 2. So now we have x's, 3x and 1x on both sides. So we're going to get those x's together. So this thing is one whole unit, you guys. So how do you cancel out a positive x log of 2? You have to subtract x log of 2 from both sides of the equal sign. Remember, you can only do it with like terms. So let's see what we have now. That's gone. So 3x minus 1x is 2x log of 2 minus the log of 5 equals 3 times the log of 2. So now we're wanting to get, wait, did I mess up on that one? I have to look at my notes, you guys. Oh no, I cannot combine those. Those are not like terms. I'm sorry. Let me back up a little bit. All right, but I do want to get these ready, but I do want these to get them on the same size, the X's on one side and the numbers without the X's on the other. But I'm not allowed to combine 3x minus 1x because the logs are different. One's the log of 5 and one's the log of 2. Okay, so since I literally cannot combine these, they're unlike terms, I'm going to write them out horizontally. So I have 3x log of 5 minus x log of 2. And then since these both don't have x's, this one and this one, I'm going to get this whole term to the other side. So what's the opposite of minus log of 5? I'm going to add the log of 5 to both sides. So on one side, I have my terms with x's. On the other side, I'm going to have my terms without x's. So once again, they're unlike terms because one's a log of 2 and one's a log of 5. So I'm going to write them out horizontally. So I have 3 log of 2 plus 1 log of 5. Okay, so now see what's going on over here. Well, I have x's in both terms, so I'm going to factor out an x. So I'm going to factor out an x. So this term divided by x is 3 times the log, drop my 5, of 5 minus the log of 2. On the right side, I don't have any x's or anything else I can factor out. All right, so now I am wanting to solve for x. So what is being multiplied by x? Well, all of this stuff. So I'm going to divide both sides by all of this so I can cancel it out. And so now that's gone. And so now x is equal to, and guess what I have to do with all this stuff right here? Put it in my calculator exactly like I see it. So we're going to pull up our fraction button. I'm literally typing in 3 log of 2 in parentheses plus the log of 5 into parentheses over 3 log of 5 in parentheses minus the log of 2 in parentheses. I'm going to hit equals, and it gives me a number of 0.892. And that is the answer. So I'm sorry I messed up on that one section where I told you these are like terms to subtract those x's. I apologize, but everything else I'm absolutely sure on. And you're going to have to probably watch that problem a couple of times just to make sure you get that one right. Okay. And I don't really, when I was doing your Hawks section 7.4, I didn't see that problem in this section, but it comes up either in your MyOpenMath. I think it's in MyOpenMath now, this lesson, this early this week, or maybe as we get farther into the lessons through the week. All right, so now once again, on these, I'm not going to actually, think about 2 to the y power equals x and then think about my transformation rules because I don't need to. I'm going to pull up Desmos. I'm going to type in this whole thing and I'm going to see what graph on these choices here match what Desmos tells me. And I'm just going to use my resources and I hope you guys do too. And I think there's 2 of those. So I challenge you to go ahead and do those in Desmos and find the right answers. And I think we're done. Are we done? Yep, we are. All right, so that was Monday night's lesson. And then I'm going to make you guys another video for, Monday and Tuesdays, then I'll make you another video for later in the week. All right, you guys have a great day and I will see you for class at 6 o'clock. All right. See you guys later.